Hey guys, it is me again. So hopefully you've already watched the first video, so lesson number 1. So if you haven't, go back watch. And then this, we're just looking at a box and whisker plot that's already been created. Let's see if we can share this. All right, so here is the box and whisker. Again, it's called box and whisker because you have this rectangle here and these 2 points, right? They're also, I know they called them, I think, upper and lower extremes. They're more commonly called the minimum and the maximum, right? So min, and over here, this number is the max, but it's the same thing as the extremes. Okay, so what is the median height? If you guys remember, let's make this blue, the median is this middle line right here. So if I look down, I think that that's a 66, right? So the median height is 66, and they even give us a value of inches, so 66 inches. Okay, the first quartile. So the reason that they're called quartiles is because you're taking the data set. So say you have like 15 numbers and you're basically slicing it into 4 different sections. So you're slicing it in the middle, and then the lower side, you're slicing that in the middle, the upper, you're slicing that in the middle. So it would actually, if you took a stick of butter, sliced it in the middle, and then slice the upper part in the middle, lower part in the middle, you would end up with 4 different chunks, right? So even though this area looks a lot closer together than like this area, they both represent 25% or a quarter of the data, right? So that's why they're called quartiles. All right, so fun fact there. All right, and then from here to here, you would also have a quarter of the numbers in your entire data set. All right, so the first quartile would be this right here. This first line is always the first quartile. So that means from the minimum number, the smallest number, to the first quarter of data being represented, right, would be your first quartile. So I look and I see, oh, that looks like it's in between 60 and 62. So let me say maybe that's about 61. It actually looks a little closer to 60, so like maybe 60.5, right? So I'm kind of estimating a little bit here. How tall was the tallest child? So again, that's talking about this maximum number right here. The tallest child looks like 70 inches. Okay. The height of the smallest child, that would be my minimum number, and that looks like 56. Okay. Okay, now we've got a couple true and false. 50% of the students are taller than 68 inches. So here is 68 inches. Let me actually use a different color. Let's do green. Or no, let's not do green. Let's do pink. Okay, so here's 68 inches. Now, if I look, right, from 68 to the end of my data, right, that's a little, remember, 2 quarters is 50 cents or 50% of the data. So I would actually need 2 quarters to make up 50% of my data. Remember, each quarter is 25%. Okay, so here it looks like we've got a little bit less. I would have to actually go from the middle, from here all the way to the end, to have half of the numbers or 50% of the data. Okay. All right, so this would be false. All right, at least, remember, at least means 75% or more than that, right? So at least 75% of the students are taller than 60 inches. All right, let's go for this color. All right, so at least 75%. So how much would 75% be, right? How many quarters? So I've got 25% for a quarter. 2 quarters is 50%. 3 quarters would be 75%. So I'm looking for 3 quarters of the data to be taller than 60 inches. So here is 60 inches. So it looks like I've got a quarter here. So 1 quarter, that's 25%. And then another quarter, 50%. And then another quarter, which would be 75%. And then we just have a little bit more, right? So a little extra. I'll put like a little plus sign, a little extra there. Okay, so at least 75% of the students are taller than 60 inches. That is true. It looks like a little bit more than 75% actually. All right, now 25% of the students are between 66 and 69. So again, how many quarters is 25%? Right, think about that while I choose a nifty new color. Let's go here. All right, so between 66 and 69, so here's 66 and 68. So 69, it looks like would be about here. 69. Okay, so from here to here. So let me look. So from here to like about here, right? So 25%, that does look like one of the quarters, right? So from this line to this line represents 1/4 of data, or 25% of the data. So that looks to be true. Now, I'm sharing this with you, so I actually can't see the last question because it's being blocked. But that's okay because I think that we got enough finished here. The last thing that I want to remind you of is that to find the interquartile range, you have to subtract the 3rd quartile, which is right here. So 3rd quartile. All right, so we have 1st quartile, 2nd quartile, and 3rd quartile. So just like the range is the biggest number minus the smallest number, the interquartile range is the biggest quartile, right? The 3rd quartile right here minus the 1st quartile. So it's basically just like, what is the distance just in the box? So forgetting about the whisker. So interquartile range would be the 3rd quartile minus the 1st quartile. So in this case, so I'm just going to put IQR for interquartile range. That would be 3rd quartile looks to be 69 minus the 1st quartile looks to be about 61. 61. So my interquartile range here is 8. Right? So not to be confused with the range would just be the highest number, which is 70, minus the lowest number of 56. But the interquartile range is the 3rd quartile, 69, minus the 1st quartile of 61. Okay, that is it for today. Thank you for listening.